Good day, children. We are meeting back again with the part 2 of inverse of a function. Today I will be discussing how to restrict the domain and find the inverse of a many-to-one function, and we will be discussing the sketching of the inverse of a function as well. Part 2, this is the part 2. Part 1 link I have attached with this. Those who are joining now can refer to the part 1 also. Look at this. If you take a function like fx equals x squared and the domain is x belongs to R. In this case, the function is a many to one, right? Many to one. Look, if you draw a horizontal line, it cuts the curve at two different places, right? Therefore, this is a many to one case. Many to one functions do not have an inverse. Many to one functions do not have an inverse. Then, how to find the inverse of such a function? In this case, we can restrict the domain. Look at this. The same thing, I have restricted the domain as x is greater than or equal to 0. Now, these two are two different functions because of the two different domains, right? Now, when you look at this, this is a one-to-one function. Now, we can find the inverse of this. Y is equal to x squared. X is plus or minus square root y. Now, f inverse x is plus root x. Why we are taking plus out of plus or minus here? We are taking only plus here. Why? Now, at the beginning I told the domain of the inverse function is the range of the original function, and the range of the inverse function is the domain of the original function. Now, fx values will be the domain of this domain is positive. Domain of the original function is positive. Therefore, range of the inverse should be positive. That's why we are discarding minus and taking positive root, right? This is the graph of the original, this side of the graph, right? This is the function with this restricted domain, then this side will be vanished. Look at this. This is the original function, right? Now, we have to sketch the inverse of this one, that is this f inverse x is root x. Now, I will tell you an important property here. It's very important. When you sketch the inverse, it is always the reflection of the original function on the y equals x line. This is y equals x line. So, when you take the inverse, the sketch of the inverse, it will be like this, right? It is reflecting this one on this line. Look at this. This is the inverse. Now, it is a rule you should remember always, right? Most of the time you are given the original and ask you to sketch the inverse. So, inverse you can very easily recognize in this way, right? You can check whether your answer is correct also. Now, look at this. Go to another example. fx equals x squared, right? Same structure, but domain is different. In this case, the domain is x is less than or equal to 0. X is less than or equal to 0. Now what you can do is, we'll first try to sketch this. This is the full domain, right, without the restriction. Now we have restricted, positive x's are not there, we took that part off. Now this is 1 to 1, therefore we can find the inverse like this, right? Now f inverse x is root of x. Now what is the kind of sign you choose, plus or minus? Now if you look at this, what is the range of this one, right? Range of this one is positive, therefore inside this will be always positive, but this domain is negative. This domain is the range for the inverse, therefore we take the negative here, right? This is the graph. Now you see, fx takes all negative values, f inverse takes all negative values, fx takes all positive values, x takes all negative, so this is positive because these are the x's for this guy. Okay, we will discuss few more problems, then you will be familiar with this. Take this one, x squared plus 2x is greater than or equal to 0, right? Now this is how you find the inverse here, plus or minus this. Now to decide what is the sign to be taken, plus or minus, you look at this. This domain is positive, therefore this should be positive, right? This should be positive. And then the domain for the inverse is greater than or equal to 2. You can see from here also, right? Then what we have is f inverse x is square root x minus 2, x is greater than or equal to 2, right? We'll look at the graphical illustration of this scenario, right? If you draw the full curve here, it will be this without domain restriction, but here we have a domain restriction. This portion of the curve is not there, so only this part is there, right? And then what to do? We have to draw this line y equals x. Remember, it is y equals x always, right? And reflect this one on that line. Look at this. This is 2 and this is also 2 then, right? We'll go to the next example, 5. This is quite interesting. fx is equal to minus x squared and x is less than or equal to 0. Then here domain of the original function is negative, therefore range of the inverse is negative, range of the original is negative, therefore domain of the inverse is also negative. Look at this. If you try to sketch this first, this is the original function, right? This portion is not there, right? We will try to find the inverse function now. Y equals x squared minus x squared, then minus y equals x squared. Now you have a problem how to take the square root of this negative, right? All this time you have heard that you can't take the square root of a negative. Nothing to worry, because this y is always negative. Look at this. This y is always negative. Therefore, that negative inherited in this y into this negative will always give you a positive answer. Therefore, you can take the square root of that. Understood? So, we can write this as, since y is always less than 0, we can always write it like this, right? Now we have to choose either positive or negative here. You know that this domain is always negative, therefore the range of this one is always negative, therefore we choose the negative, right? Okay, you can go through this back again and think a bit and see. We'll move on to the next example. Look at this. It is the same scenario, but the domain is different. Now I asked you to stop this video here and then try it all by yourself and then come back to the video. Then in that case you can see how much you have understood, right? So we will try and see. Gx is equal to minus x squared, right? And then we will try to plot this. So sketch this, and this is the positive side, right? Earlier we drew the negative side. Now it is the positive side because our domain is positive x's, right? And then we will take the inverse function y equals minus x squared minus y equals x squared. Here also you can take the square root without any problem because all these y's are negative. Therefore we can say x is this, right? Then this domain is positive, therefore the range here is positive. Therefore we have to say g inverse x is positive minus root x. X is less than 0. So we can sketch this. First we draw this line y equals x, and then reflect this one on this onto this side like this. This is the inverse, this is the original. Okay, I have always used this blue for the original and red for the inverse, right? Seventh one, look at this. Fx equals x minus 2 whole thing squared minus 3. X is greater than or equal to 2, because this is a function like this, right? X equals 2 is a symmetric line. If you take one side of that only, it will become 1 to 1. So x is greater than 2 we have taken here. Then our minimum value of the function is minus 3. Therefore range of the function is fx is always greater than or equal to minus 3, right? Now look at this graph of this. Right, this is the graph of this function, and then we will look for the inverse. Y is equal to this, y plus 3 is equal to x minus 2 squared, then square root of y plus 3, and then we discard the negative here because y should always be greater than 2 here. This one, the f inverse x should be always greater than 2. If you take minus here, it will be less than 2, something will be deducted from. So therefore we take plus here. This is the f inverse function. X is here greater than minus 3, this one, right? So we will try to sketch this. Right, this is the okay.